BGP, which stands for Border Gateway Protocol. BGP is a system used by routers to communicate and share directions on the internet. Two routers connecting to each other form what is called a peering session. So we see here, this here is a peering session, here, all this here, these are peering sessions. This session lets them exchange information about how to send data around the internet. Unlike some other protocols, BGP doesn't automatically figure out how to connect. It requires manual setup and coordination between the routers. BGP is unique in that it's a path vector protocol. When routers share routes, they also share a list of autonomous systems or neighborhoods that the data pass through. So we see here, this is one AS101, AS102, we see these here. This helps routers decide the best path for data and avoid sending it in circles. If a router sees its own neighborhood in the path, it knows not to send the data back there. There are two types of BGP. External BGP, which is eBGP, and internal BGP, which is iBGP. eBGP connects routers in different neighborhoods, allowing them to share routing information. So, like this here, these two autonomous systems are connected via eBGP, eBGP, like that. iBGP, on the other hand, spreads the information within a single neighborhood. So the connection inside this AS would be iBGP, the one inside these neighborhoods here. To link neighborhoods, ASs, there's a special zone called the demarcation zone that we see here. The demarcation zone. It's like a meeting place that doesn't belong to any specific neighborhood, but carries data and routing information between them. This here. BGP works by routers learning routes from their neighbors, applying rules, and picking the best path to store in their routing information base, which is called a RIB. This chosen path is then shared with other routers, helping data find its way across the network. On this diagram here, we see in the BGP process, some are discarded, some info is discarded, some is accepted. The one that is accepted goes to the BGP table, then the routing table, and the forwarding table. And we see here the out process where the best path is taken out and gone to a different autonomous system. BGP, in a nutshell, it learns multiple paths via internal and external BGP speakers. It picks the best path and installs it in the routing table. The best path is sent to external BGP neighbors. Policies are applied by influencing the best path selection. It allows each neighborhood to discover routes to each other and apply rules to control data flow, ensuring efficient and reliable communication across different autonomous systems.